Welcome back, everybody. So today we're gonna check for GFP on the petunia plants that were transformed in the beginning of the semester. And here you can see the inside of the flower, and Linhan is gonna point, after he opens it up a little bit, he is gonna show you the anthers.
Oops.
And
This is the pistil, like the female part.
okay.
I just got rid of this.
So he just got rid of the female portion of the plant. And
Yeah, so
very carefully actually took the anthers with the pollen off and is gonna put it into a little Eppendorf tube, so 1.7 ml Eppendorf tube that contains 200 microliters of pollen germination media. And the next step is gonna be to vortex it for probably about 20 seconds or so to get rid of the pollen grains. So the pollen germination media contains sucrose, PEG, polyethylene glycol, and several salts. After the vortexing, he will then dispense the solution containing the pollen and the pollen grains. And you can see there is a color change now. Okay? So he will then put it into a 15 ml tube, which he will now incubate for 2 hours at 30 degrees Celsius at 200 to 250 RPMs. So for demonstration purposes, this was already done before. So let's assume that 2 hours have passed. And we will move directly to the part where a drop of this solution will be put on a microscope slide in preparation to check for pH for GFP. So he carefully puts a drop in the center of the slide, which is about 30 to 40 microliters, then takes a cover slip to cover it up. So this has been prepared before, so we're going to take a look at the GFP expression for our next step.
right now we're going to take a picture of the slide we just made of the pollen tubes. So first we need to take a picture of the pollen tubes without the GFP filter, so we can count how many pollen tubes we can see in this picture, and then we can switch that to the GFP filter, and then we can see how many of the pollen tubes that has GFP fluorescence in their tubes. So I just loaded the slide right here, and as you can see on the screen, it's really blurry, so I'm going to adjust this fine tuning button just to make sure we see a clear image of the pollen tubes. Oops. And just move this a little bit, move all the pollen tubes to the center of this picture. Yeah, okay, so you can see this is the pollen tube, pollen grain, and the pollen tube will like the tail will grow out when we shake it for like 2 hours. So first we need to take a picture of this image just to know how many pollen tubes in total we can see in this image. Okay, so after we take a picture right here, just capture, and we go back to live, and then we're going to apply the GFP filter on it. So the first thing we do is to turn off the light and switch this wheel to the GFP filter, which appears to be blue here. And the next thing, we need to make sure that it is exposed for long enough, so we're going to move the exposure time to the maximum, which is 10,000 microseconds, and then we take a picture. So that ensures we are taking the GFP fluorescence picture of. Okay, so that's the GFP fluorescence picture we just took, and as you can see, half of the pollen tubes are wild type, which does not have any GFP fluorescence, and half of them has really strong GFP fluorescence basically in the pollen tubes, and some of these are just autofluorescence of the slide. And the reason why we see half wild type, half GFP, is that the GFP transgene is of only one insert in the genome. So, but pollen is diploid, which means it only has one set of chromosomes. So half of the pollen will have the set of chromosomes that carry the transgene, and half of them doesn't. So you can see here, half of them does not have any fluorescence, while half of them has really strong green color in these pollen tubes. So that indicates the transformation works, and we have actually the GFP fused protein expressed in pollen tubes.